Hello, fellow Haskellers! Welcome to Giggles is You, the show in which I implement a clone of Baba is You in Haskell while I answer your questions, if you have any. So, since the last episode, I implemented this extra data type word because what I want to do today is to implement the quintessential feature of Baba is You, which is that as we push the blocks around, it took forever to implement pushing, but now that we finally can push blocks around, we can form sentences such as Giggles is you, or wall is push, and then that changes the rules of the game. Previously the walls were unpassable, but after you phrase wall is push, now you can push the walls and escape. So in order to do that, I need to I already have like a bunch of words that I can push around, but it was insufficient. What I had before was this, and elsewhere I had something like entity was either an object with that name or a piece of text with a name on it, and so I had both an object, Giggles, like just the character that we move around, and I also had a piece of text that was just a block with the word giggle written on it. And those were two different kinds of entities in the world, one which is moving around and the other which is being pushed. And that was insufficient because I realized that there are some words, for example, is and you, which are not names of objects in the world. All the objects do have a word corresponding to them, namely their name, but there are more words than that. So that's why I created this new data type, which includes all of the names, but also has the other important keywords like is, you, stop, and push, corresponding to all of the rules which we support so far. And so as a consequence of that new type, I made some other changes. So let's see what happened to this entity type I just mentioned. It used to be that all of the entities in the level were either an object with a particular name or a piece of text naming an object. Now the piece of text can have any word on it, not just the name of an object. And then a few consequences of that. In my list of all of the specially recognized names or other characters, in my textual representation of the levels, most characters represent an object that is just that uppercase character in a circle, because my goal is not to make the prettiest game. And there were a few letters that were recognized specially, like G for Giggles and S for sheets, and so I added a couple more special cases for the words is and you and push and stop. And stop was a slight problem because S was already being used for sheets. The other playable character, well, everything is a playable character in this game because you just have to form the name of the thing you want to play as is you, and now you can move the thing around. So I just renamed sheets. Now its special character is H instead of S. And as a consequence of that, just the parsing stuff. What changed in this line? I don't think this line should be changed. It was 400 by 300. Okay, so yeah, I have to extend the code which draws the text so that I know how to draw the other words. Just, for example, I draw a piece of text with the word unit as just the text U. Very easy. I already looked at that. Some code for parsing the characters, printing them. All of the tests where I was using S as sheets now has to be, well, now it has to be H as sheets, but now that I'm thinking of it a bit harder, shouldn't it be S for stop? Because like the purpose of all of these tests, like the reason I used S in the first place was because I wanted to talk about an object which was stop. And in fact I had this bug in a previous episode in which I struggled to understand why my rules weren't working. It's because I was trying to assign the rule to an object named S instead of to the character sheets. And well, if I write capital S, will it even work? Or well, is there an object called capital S, or will that be interpreted as stop? It's only lowercase s that's interpreted as stop. Because of those complexities, I think I will just keep it as is with H as sheets that has the stop property. Alright, those are just renaming all of the S's to H's. I've already showed you this, and that means I've shown you everything. Yes, so text entities can hold words other than names, is what I did. Alright, so with that done, I can now start thinking about how will I implement that new feature, that quintessential WebISU feature of forming rules. Well, I need to recognize when a sequence of blocks on the level is forming a sentence and to interpret it as a rule. So that's a parsing job, right? I have a sequence of tokens and I need to interpret them into something else, or if it's some sequence that makes no sense, like is sheets U or sheets U is or anything else that is malformed. Well, if I was just trying to parse something, it would be a parse error, and I would like display an error message to the provider of the text or something, but in WebISU it's just nothing happens, no new rule is added. You're allowed to arrange blocks however you want, it's just when they do form a rule that the rule is added, otherwise nothing happens. Yeah, I want to use parsing. And one of the reasons I want to use parsing rather than just like going through the list and seeing if there's any like 3 blocks one after the other and just like checking if it's a name, is, and then U, is because one of the inspiration behind this show was, as I explained in the first episode, a video by the author of WebISU in which she explains that it was very challenging to implement the rules and that he had to write a very different code path for parsing, well, for I don't think he called it parsing, for interpreting rules such as Baba is you, and for rules such as Baba on grass is you, because there's a different number of tokens. And well, in Haskell, Haskell is pretty good at parsing. That's one of its strengths, and so that's one of the things that made me think that reimplementing Baba in U, reimplementing Baba is U in Haskell might be an appropriate choice of language to implement it. So that's why I started this presentation, this show. Okay, so I want to parse. Which library am I going to use to do parsing? And I'm quite opinionated about that. And rather than tell you, I will definitely tell you why I hold my opinions, but before I do, I want to show you that others share my opinion. A few episodes ago, we followed Gabriel Gonzalez's recommendation regarding how to structure our code in terms of modules and components, I think they call it, in Cabal. Like maybe they're called targets, not sure. I think they're called targets in Stack and components in Cabal. Like the library and the executable and the tests are 3 different components, and Gabriel recommended to put everything in the library and to have very thin wrappers in the executable and tests. So he has more great recommendations about parsing. He recommends using Megaparsec, which is like the most popular parsing library, for lexing tokens, and Earley, which happens to be a parsing library I hold in high regard, but haven't used much yet, for LR parsing of the token stream produced by Megaparsec. So I was quite happy when I saw this tweet because, I'm not such a big fan of Megaparsec, despite the fact that it's such a popular library. And the reason for that is because it presents an API which, in my opinion, is not very composable. It has a very good reason for that. Well, first of all, let me tell you what this idea is. It is that if you know how to parse an int, and you know how to parse a string, maybe that's not the best example. Okay, let's start with that example. If you know how to parse an int and you know how to parse a string, you can use the brackety pipe operator to construct a parser that can parse either an int or a string, and that will work. But if you know how to parse an int and you know how to parse a double, and you take the parser for int, brackety pipe, the parser for double, you will not get a parser that can parse either int or double. So that's surprising and uncomposable, because I should be able to compose smaller parsers into bigger parsers using intuitive combination operators. And the reason why you don't get a parser that can parse either an int or a double is because the semantics of a Megaparsec parser, and indeed many other parsing libraries use this same approach, again, for good reasons, for performance reasons. The semantics is not that I'm either successfully parsing a value of type int or failing. It's that I'm either successfully parsing an int, or I'm consuming at least one character that looks like it's going to be an int and then failing like forever. Like I can't compose it with another parser after that to say if you failed, try something else. Or I fail without consuming any characters, in which case I can compose it with another parser and then try that instead. And so, the fail forever part seems scary. Why did they add this in? And again, it's for performance reasons. Because if you're indeed using backtracking, then if you think about it, right? If you have, like at the beginning of your program, you're parsing an int, and then you do a whole bunch of other parsing tasks in order to parse like the rest of what I said at the beginning of your program. Because usually ints and doubles appear in the program, but like whatever is the file that you're parsing, like it could be a data file, it doesn't have to be a program. Like if you have 100,000 rows, and like the first entry of the first row, let's say it's comma separated values, like but before the first comma you have an int, when you parse the comma, and then you parse the rest of the entries in the first line, and then you go to the second line and the third line, and then you continue all the way to the end, and then at the end, let's say you have a string that is not terminated by a double quote, you're missing that. And so the format requires an ending double quote for all strings, so the file is malformed. But instead of failing by saying that the file is malformed, you have to go all the way back to the beginning and ask, what if I had parsed that as a double instead? Maybe then it would work. And of course it wouldn't work, because you still would have the missing double quote at the end. But if you do the backtracking, that is the natural implementation of parsing an int or a double, which is that if it doesn't work, you come back, then, well, not just like immediately after parsing the int, like if you want to do it in a composable way, you have to be able to backtrack from later to this earlier decision, because maybe instead of being comma separated, maybe like it's like dot separated, in which case it might matter whether you interpret let's say there's 12.13 new line. It might matter whether you interpret that as a single double or as two ints separated by a dot, because maybe later on you have a guard which checks that all of the lines have the same number of entities, for example. So if you have 12.13 and then foo.bar, and both of those successfully parse as strings, then you know that it was actually two ints and not a double. Right? In order to be very composable, you have to be able to backtrack from later. But it's very inefficient to do that. It's exponential. You have to go, like if you have 100,000 lines, that each can be parsed either as an int or a double. Like you have to try all of the combinations of parsing the first line as an int or double, the second line as an int or double, like and so on for like 100,000 times. So it's a 2 to the power of 100,000. That's like impossible to enumerate all of those possibilities. And so, yeah, they have a very good reason to do it, and so that's why the solution that is often recommended, which is, well, if you don't like brackety pipe, just use your own operator that does try the first thing, brackety pipe, something else, which has the semantics that I want, that you combine two parsers into one parser that parses either the first or the second, because try converts the I've parsed a few characters and I'm failing forever into I haven't parsed any characters, let's try something else. That's why the solution is not super appealing. It has the correct semantic, but not the right performance. And so that's why I'm quite interested in other approaches to writing parsers that do not force the users to make this difficult choice between performance and intuitive composable semantics, and Earley is one of them. So they say LR parsing. What is an LR parser? It reads input text from left to right without backing up. Right? It does not backtrack. That is exactly what I want. And also, somewhere in its documentation, it will say that, the way in which you describe it, you still use brackety pipe, but this brackety pipe has a different meaning. Instead of meaning you backtrack, we are using it, well, it's not really a different meaning, because when we use Megaparsec and other parsers based on parser combinator libraries, we are describing the BNF syntax, like the small form, of the grammar we want to parse, using brackety star for composition and brackety pipe for alternation. But the way in which this corresponds to Bacchus NOR is like a bit indirect, right? We give a semantic to those combinators in terms of searching and backtracking. Whereas here, we are describing a grammar and like this construct the grammar as a value. We have a value of type grammar, and we could like list it and print it and examine like what are the alternatives. And so that makes it possible for Earley to then compile this data representation of the grammar into like presumably something like deterministic finite automaton or something like that, that parses the whole thing through. That's the library I'm excited about, which again I haven't tried it much, but I'm excited to have an excuse to use it. So let's just copy the example from the documentation, and also of course add Earley to our list of dependencies. Test all, yeah, sure, let's investigate Earley via a test. Well, what do I even need to import? This example is incomplete. Text.earley.grammar. Text.earley.grammar. And well, I think it's going to be temporary. No, I can have some real tests, which are going to be exercising my grammar once I write it. This does not type check. It also has a weird indentation. Something like that. Of course, it was not the indentation that was causing it to not type check. Oh, it's presumably because mdo is, I'm not sure why it's called mdo. I would have called it rdo because it's a keyword for the recursive do language extension. Recursive do. And now the error is a different place, so I think that helped. And what this recursive do language extension does, weird thing, I have to use pure instead of return, is that it allows variables that are bound later, like x3 and x2, to be used earlier. So here, with a regular do, then this x2 would be out of scope because it's defined after, so it's only available from here for the line afterwards onward. But with mdo, it is in scope. What is not in scope is exp. So presumably, yeah, this is probably just a very small subset of what we need to write in order to have a full example. Do they have more? Maybe on GitHub, they might have an example folder. Examples. Exp, there you go. Yeah, recursive do and all of the things that I need in order to run it. Oh, it's gonna... I want to keep my indentation. It's fine, it's fine. I just want to run it. The indentation doesn't matter. Putting that at the top. Okay. The import of Earley.grammar is redundant. Fine. The binding for rule. Yeah. Yeah, so I have rules in Giggles is you, like something like name is push wall is my internal representation of the rule wall is push. but here they also have rules, as in a production rule, I think is the term of art, for a grammar in the sense of the BNF edition. So yeah, I just want to experiment with the library, so let me comment out a bunch of things and just I guess I call up the main function and comment out the thing, most things actually. Let's just keep their reports. Okay, so I don't know why I have this text.early.grammar, given that they only have text.early here. Oh, it's because I added it when I was looking at this. Okay, so it runs, but it fails. So good thing I ran their example. Their example doesn't even work. Pattern failure in do expression 182. Oh, because we need to give it an argument. Okay, okay, no, not my fault. I mean, not their fault. The example is not passing. So they just expect a string. So a string x, that x equals. Oh, actually, I can parse a string x. Bet parses already something that they export. What am I parsing? I don't even know what the kind of string that they expect look like. To give an example? No, but I should be able to figure it out from the grammar. So a token plus can be a token, and so can star. So 1 plus 2 times 3. All right, excellent. So it parsed 1 plus 2 times 3 into a few components. 1 plus 2 times 3, I guess it's words, which split it into a number of tokens. But since it says that all of that is unconsumed, I guess I failed to produce a string that parses. So let's take a look, a closer look at that, at those production rules, at this grammar. So it says that I can have something plus something. I have that. Something times something. I have that. Oh, and the last possibility is parenthesis or an identifier, not a number. So if I say x plus y plus times z, there we go. Now nothing is left unconsumed, and it successfully parsed into I guess give me a list of all of the possible successful parses. Okay. So the outermost constructor is an addition of x plus the multiplication of y and z. Great. And I guess I could test other things as well. If I force it to parse the left, then it doesn't work. Oh, because it uses words to split tokens, so I have to put some spaces. Great. So now the outermost constructor is the multiplication. Okay, excellent. So now that I have a working example, I should be able to modify the grammar into something else. And let me move the grammar to a different file, probably. I guess grammar would be a good name for that file. So I no longer want this. I do want parse because that's the name of my test. And I want to import Giggles is u.grammar. And in Giggles is u.grammar, I only have the definition of the parser, and I guess it's the type for now, but not the test. Okay, bunch of warnings. I know I can configure GCID to run the test despite the warnings, but I want to fix the warnings. So line 16. Yeah, because I no longer need to import any of those things because it's only relevant to the definition of the parser. No, that is not true. Yes, full parses is used here in the parse function. Okay, and can I uncomment everything else? There's still some clashes. It's not complaining about rule being ambiguous, so that's good. But it doesn't like the imports that I added when I pasted them from the example. Excellent. Wait, no. Oh, so now that I fixed the imports, it is complaining about the rule. Okay, so I guess it was not an error. It's not that the word rule was ambiguous, but rather that there is some shadowing. Okay, no problem. I will only import full parses. And the parser, I guess. Cool. Okay, so now I have a bunch of tests, including a test for a parser. It doesn't parse the language I want to parse yet. Okay, so I similarly want to simplify this file to only have the parser. Do I need any of those language extensions? Yes, of course. I need recursive do, and that's the only one I need. Okay, good. So now I have a nice file structure. The grammar, that's for the grammar. Okay. Next, I would like to change the grammar so that parse is something I care about. And what I care about are the rules. Where are they defined? Presumably in rules. Okay, yeah, here they are. Those are the 3 rules that I support. So this in Giggles is u.rules, and there are 3 of them. Well, yeah, it's currently redundant because I'm not returning it, but I will produce a rule. And I think, usually the convention when writing parsers is to use the same name as the type you're parsing, rule, which I find a bit confusing because I like to use the lowercase name version of a type for the variables that have that type. So I think I would be importing the grammar qualified for that reason. Qualified as parser, or I guess grammar. Grammar.rule. Oh, not well, since I want to parse a rule, it's going to be hard to get around the fact that the word rule is ambiguous. So, yeah, it's this rule that conflicts with this rule. So, as usual, or rather, as I explained in the last video what I usually do, which is to add an underscore in these kinds of situations in order to avoid conflicts. It's an easy rule that works all the time. Okay. And now, of course, I'm constructing a value of type x, but I don't want that. I want to construct a value of type rule. So what are the three constructors? There is name is you, name is stop, and name is push, presumably in a different order. Push stop you, just so that it's alphabetical, sure. Push stop you, and those are three different productions, production rules. There are three alternatives, so I don't think I even need more than one rule. I just need those three. Okay. Name is push, name is stop, name is you. Okay. And well, now we're encountering the same kind of situations that I mentioned before with the integer and the double, where parsing the first few characters, they begin with the same characters, so you can't immediately distinguish whether it's an int or a double. Like from the first few characters, you either have to backtrack or do whatever is the smarter thing, which Earley is doing. So, because now we'll have something like Giggles is, and whether it's push or stop or use is going to be one of those three rules, and it's too early when we only see the word Giggles and is to figure out which of the three it is. But presumably it's like automatically factoring out the rule so that parsing Giggles and then is, and then regardless of, depending on the character I see next, since it's not allowed to backtrack somehow, it's really choosing the constructor later than what I'm writing here. But I like the flexibility of being able to write it in that order. And that's the advantage of using an approach, a data-based approach, is that the data can be manipulated. If the way in which we like to write it is in one order and the way in which we like to execute it is in a different order, we can manipulate the data to be in a different order. Okay, so just like wait, no, I was about to say just like the example, I want the input to be a list of strings such as Giggles is you, right? But then I realized, no, it has to be a list of words. Okay, so I need to import word of those things. So one of those two strings is going to be word. Not sure which one. Let's see in the documentation. Did they explain grammar right away? No. Okay, so prod RETA, prod RET, so is it E or T? E is expected and T is terminal. I think it's terminal. So this one should be word. Need to hide the word from the prelude. You know, an unsigned integer is a word in computer speak, but I don't care about that interpretation of the word. I care about the Baba is you interpretation of the word. Okay, so none of those. Wait, so named token is apparently how we parse a particular token. So named token, if it was, what would be the word for Giggles? It's name word of the name Giggles name. So named word Giggles name. And what would be the word for is? It's not named word. It's name word. Okay, and there's is word and so on. So token is word and you word. Great. And the same thing. Like for now, I'm just trying to get something which compiles. I of course don't want to hard code Giggles. Giggles is you is stop and is push. You stop and push. And I don't need this ident thing. Alright, so I know it's wrong, but I would have expected it to parse. What is it? Parsing? Could not match type word with char. Is it the wrong one? R-E-T-A. I think I'm now polymorphic in E. I think it was the type of the thing that came after the question mark, which would be helpful if I was producing an error message to the user, but I'm not. I'm just ignoring the rules, which don't work, don't parse. Could not match type rule with word arrow rule. Oh, okay, okay. I'm applying a rule to any argument because name is push is a constructor of type name arrow rule, but here I'm applying it to this word that is successfully parsed and this word and this word. So it expects name is push to have type name arrow name name or word arrow word arrow word arrow rule. So I need to use the left bracket star. I've been thinking like, okay, so I'm like some people called it like the TIE fighter operator or something like that. It has a variety of names, and I like consistency, and so I was thinking of naming this family of operators like brackety dollar, brackety star, as opposed to having to come up with like, okay, this one looks like a TIE fighter, what does the one with the dollar look like? Right? And this one I could either call the left brackety star, but it's a bit long. Like, because I could have called this the less than star greater than operator, right? But that's very long. Brackety star is short-ish. And so I was thinking, if, like, you know, in physics, I think in quantum physics they use something like the bracket notation. I think it's like this. Like you have a value in between brackets, and you have a this is a bra, and this is a cat, something like that, when you have half of it. So I was thinking of calling it a bratty star and a catty star. Don't know if it will stick, but that's my proposal. So, 15. Well, first of all, is the first attempt working? No. Okay. Why not? Couldn't match word with name. It is name word. It's a constructor for a word. Okay. But name is push takes a name. Ah, okay, okay. So I need a different rule for a name. Okay, I'm starting to realize something now, which is that the thing on the left of the bracket, if I have rule dollar or something, like that's the name of what I'm parsing, not this. So I guess this is the grammar. And if this is indeed the grammar, then I don't need, well, it's not called rule underscore, it's not the name of a type. Okay, well, grammar is a type, but it's not a type in my domain. It's just the grammar. I can import it unqualified after all, right? Okay, so to parse a name, I expect a name word, and that's the one I'm parsing. So how do I express that? Well, there was a where clause earlier that I deleted that had a good example of that, where they wanted to parse, in their case it was a string, and they were accepting any string as long as it began with an alphanumeric character. But they're returning a boolean. I was expecting it to return a maybe of the parsed value. This way I can transform the generic word into a more specific name if I've parsed correctly. So maybe I can search for whatever ident called. It's satisfy in Earley. Let's see if either right next to it there is something that I want, or if I can search for this type, and I would like to return an A instead of a T, given a function from T to maybe A. Does that exist? Terminal, thank you. So terminal produces a prod. So I think I'll put that in a where clause. It doesn't look monadic, even though it's a prod something something A. I see that we are in the grammar monad, not the prod monad. Prod is the data for the productions. So a name is a terminal with a function that matches on the word, and if it's a name word with a word, I return that word, and if it's anything else, I do not return anything. Okay, so instead of name as a token, that is, I have a name here, and I give you the guys. Guys, match expected type prod. It's still not working. Oh, well, this line I already have defined elsewhere. Could match type E with word. Sure, maybe by default it uses the same as what I expect. The elements I am consuming maybe are being used as the things being used in the, not the things, I should use more precise words when I'm streaming. The elements which I am consuming appear to be used in the error messages. So I think that this E is used in error messages. So that's why I have to use the same type here and here, I believe. Couldn't match type word with char. So when I am confused by the error message, I like to give a more precise signature. So I expect this to be a prod RET name. Well, T has to be specialized to word. 153, and it still complains. So it correctly inferred that the type should be prod RE word name. But it was wrong. Oh, it's in a different file. 153, because there aren't 153 files, 153 lines in this file. I just typed the command to go to line 153, and it brought me to the last line, but that's not the line on which the problem was. Okay, so on this completely different page, different file, grammar, I've just changed its type to be producing a rule that's not recent that I made the change. What I made the change is that the type of the errors are now different. Yeah, I'm a bit confused about that. Can I bring this back? Why is it expecting it to be a word? Is it because I do not have here an annotation? What if I did write an annotation? No, that would not have helped. Couldn't match type word with char. Yeah, they really do want prod word for some reason. It's because of named token. Yes, named token produces a token, consumes a token, and has an error message of type token. And I'm curious to see what about the question mark? What? I would have expected it to take something else, like a concrete E. Okay, now I'm very confused. How do I change from a prod RETA to a prod RE prime TA? How do I change the type of what is being annotated? Like, I would have liked the exact same type as question mark, but I annotate it with an E, but then that changes the E to an E prime. Maybe I'm not supposed to use named token in the case in which I want to use a different description of what I'm parsing than the type of the token. Match a single token and give it the name of the token. Okay. Oh, and indeed, token is the same as that, but it is polymorphic in E. Okay, so that answers the question. It's a new token. I will use token. And now I can use any E, because I'm not bothering to give names to anything, because I don't need to produce nice error messages. Couldn't match type Giggles is using type of word with char. still on line 153. Parser takes a list of strings. Same thing as usual. Import preview typing word. I want to talk about a different kind of words, and now I can test it with things like name word equals name is and name you. Still expect string somewhere. It's a bit hard to read. Expected type, grammar, R. This is the T? That makes no sense. What happened to the RTA? What? Well, I don't know what happened down there, but up here, words is clearly not gonna work. I've already received the list of words, it's already divided. Okay, great. So, Giggles name is word and you word. Okay. Ambiguous type variable. Okay, well I can make it more precise. I can say that it's a string. There we go. Now it's compiling. My code was too polymorphic, which meant that it could be interpreted in a variety of ways. Usually being polymorphic is good because when I need to instantiate it as a specific type, the compiler figures out what is the type that I need, and it specializes my polymorphic code to work in that specific circumstance. But in this case, the specific circumstance in which I was using it did not imply a more precise type. It was just saying whatever. It could work in any context. I don't know which context you want me to work in. So I don't know what to specialize E to. And I don't care what it wants to specialize E to, I just want to run it. So I made it not polymorphic instead. Alright, so that was name is push. Let's do the other two. Name token is, let's replace all of those. Name token with name, no, with token. His name as well. Is where the step is you, and it's now short enough that each of them can fit in the line. Amazing. Align them. Excellent. Isn't Earley nice? And it correctly parsed Giggles is you as name is you, Giggles name. Excellent. So I have not yet, I haven't even ran the game. I have not yet changed the rules of the game according to what I've parsed. In fact, I haven't even tried looking at the blocks, how they are arranged in the level in order to produce some rules. I think I will do that next time. Because I think this is a good starting point. I've successfully written a parser for all of the rules that I support so far in the game. Well, so far all of the rules have only 3 entries, so it's not a very good demonstration that Haskell is great at parsing and a better fit for implementing a game like Baba is you, so that we can support Baba on grass is you just as easily as Baba is you. But let's leave that to a future episode. All right. So I think that is enough for today. So see you next time!